In the previous example, we had the angle in quadrant number 4. Quadrant number 4 will give us angles from 270 to 360. And we saw how the sine, cosine, and tangent ratio will sometimes give us a positive and sometimes give us a negative. When you are in a different quadrant, they will give us different signs. And here in example number 2, we will look at an angle that is in quadrant number 2. 210 degrees is bigger than 180, and in fact it is bigger than 180 by something that we are familiar with, special angle. 210 degrees is bigger than 180 by 30 degrees. And that means we will now be using the 30 degree special triangle to come up with the ratio for these three lines on this right triangle. This right triangle will give us ratio 1, 2, and root 3. But that's not quite yet. We're not quite done yet. Knowing how this triangle is on the left hand side and under the x-axis, these two lines will have a negative value. And that means for the SOHCAHTOA that will involve either the adjacent or the opposite, they will give us a negative ratio. Questions?
Why is the terminal arm not negative as well?
Because when you are using the Pythagorean theorem, using a squared plus b squared equals c squared, you would have squared the negative to positive, and you would have squared the negative root 3 to positive 3, and therefore as you take the square root of this line, you are to consider this hypotenuse the length of this terminal arm, and the length of this terminal arm will always be positive. The hypotenuse will always be positive. So this is something that you need to remember. The opposite and the adjacent can be positive or negative, depends on where you draw your triangle, but your hypotenuse will always be positive. So now using the reference angle, 30 degrees, we can now calculate the sine ratio for 210 degrees. Using this triangle, we want opposite over hypotenuse. And in this triangle, I can use this angle instead of 210 to find the ratio between its opposite and the hypotenuse. So as you can see, once again, the sine ratio will be negative in this quadrant. Here, negative 1 over 2. Cosine in this quadrant. Any cosine ratio will involve the use of adjacent and the hypotenuse. And in this case, 30 degrees, the adjacent side will be here, and the hypotenuse will still be the same thing, positive 2. So altogether, negative root 3 for the adjacent, positive 2 for the hypotenuse, we will end up with negative root 3 over 2. So we are getting a negative ratio for cosine 210 degrees. And finally, tangent 210. Opposite over adjacent. The line opposite to this angle, -1. And here is the adjacent. Opposite over adjacent will now give us -1 over -√3. And that will simplify to a positive ratio. So combining what we saw in example 1 and in example 2, we had a negative ratio for sine, a negative ratio for cosine in this quadrant, and a positive ratio for tangent in quadrant number 3. Any angle that goes between 180 and 270 will give us a positive ratio for tangent. But then back in example number 1, we had a negative ratio for sine, a positive ratio for cosine, and again a negative ratio for tangent. In this quadrant, anything that goes between 270 and 360, in quadrant number 4, you will see a positive ratio only for cosine. If you think about the SOHCAHTOA in quadrant number 1, if you have a triangle in quadrant number 1, all 3 lines on this right triangle would have a positive value. Positive value, positive value, and positive value. And the SOHCAHTOA will always give us a positive ratio at the end, because all 3 lines will have positive value. So in this case, in quadrant number 1, sine theta would be positive, cosine theta would be positive, tangent theta would be positive, everything here will give us a positive ratio. In this quadrant, only the cosine give us positive. In quadrant number 3, only the tangent will give us a positive. So the last quadrant, what would give us a positive? You had the cosine, you had the tangent. What else do we need? Sine. The sine ratio would be positive. The reason why we have a sine, we have a positive of sine in this quadrant is that as you draw your triangle in this quadrant, the opposite will have a positive value as this line goes in the positive y-axis. Your hypotenuse will guarantee be a positive, and anything that involves the adjacent would now be negative because this line is now on the negative x-axis. So anything that involves adjacent in this quadrant will give us a negative ratio. So here, to make it consistent, I have sine theta equals positive, cosine and tangent will give us negative. To make it easier to remember, instead of finding the SOHCAHTOA, paying attention to the positive and negative in each quadrant, there is a better way to remember this. You will always have A, S, T, C for positive. some book actually start the acronym from quadrant number 4, giving us a word that actually makes sense. CAS, yeah. CAST. But I don't like that idea because we usually will have the angles measuring from 0 degree, and I don't like starting it from quadrant number 4. CAST start from quadrant 4, but ASTC start from quadrant number 1. So I would rather use ASTC, such as all student take calculus. At least this is what you are doing here. All students take calculus. So that makes it easier for you to remember. Those are the places where the sine, cosine, and tangent will get us a positive value in division.